In the vast expanse of our solar system, Earth is constantly under the watchful gaze of astronomers and scientists who are working tirelessly to protect our planet from one of the most significant cosmic threats, asteroids. These ancient remnants of the solar system's formation, ranging from small rocks to massive boulders, have the potential to cause catastrophic damage if they collide with Earth. The concept of planetary defense against asteroids has become a critical area of research, combining advanced technology, international collaboration, and innovative strategies to detect, track, and mitigate these celestial hazards. The first line of defense is early detection. Using ground-based telescopes and space observatories like NASA's Near-Earth Object (NEO) program and the European Space Agency's ESA Fly-Eye telescope, scientists continuously scan the skies to identify and track asteroids that could pose a threat. These systems are designed to detect even the faintest objects moving across the night sky, providing crucial data on their size, speed, and trajectory. By cataloging these near-Earth objects (NEOs), researchers can predict potential impacts years or even decades in advance, giving humanity time to prepare. But what happens if an asteroid is found to be on a collision course with Earth? This is where planetary defense strategies come into play. One of the most promising methods is the kinetic impactor technique, which involves sending a spacecraft to collide with the asteroid at high speed, altering its trajectory just enough to divert it away from Earth. NASA's Double Asteroid Redirection Test DART mission, launched in 2021, successfully demonstrated this approach by impacting the asteroid Dimorphos and changing its orbit. This groundbreaking mission proved that we have the capability to deflect an asteroid, at least on a small scale. For larger asteroids, other methods are being explored, such as the gravity tractor concept. This involves positioning a spacecraft near the asteroid and using its gravitational pull to gradually shift the asteroid's path over time. Another innovative idea is the use of focused solar energy or lasers to vaporize part of the asteroid's surface, creating a jet of gas that acts like a natural thruster to push the asteroid off course. While these methods are still in the experimental stage, they represent the cutting edge of planetary defense technology. International cooperation is also a cornerstone of planetary defense. Organizations like the United Nations Office for Outer Space Affairs (UNOOSA) and the International Asteroid Warning Network (IAWN) bring together scientists, governments, and space agencies from around the world to share data, resources, and expertise. This global effort ensures that no single nation bears the burden of protecting Earth alone and that the best minds are working together to address this universal challenge. As we continue to explore and understand our solar system, the importance of planetary defense cannot be overstated. While the likelihood of a catastrophic asteroid impact is low, the consequences are too great to ignore. By investing in advanced detection systems, developing innovative deflection technologies, and fostering international collaboration, we can ensure that Earth remains safe from the threat of asteroids. After all, our planet is not just our home, it's the only one we have. Let's protect it together. Outro. Thanks for watching. If you found this video informative, don't forget to like, share, and subscribe for more fascinating insights into space, science, and the future of humanity. Stay curious, and let's keep exploring the cosmos.